All right, 9B notes. We're going to talk about exponential functions in real life, particularly when it pertains to money. And so we're going to talk about sort of an exponential growth, exponential decay, more growth here on these notes today. Okay, so starting back here, our parent function for exponentials is y is equal to 2 to the x power. Um, the format is y equals a times b to the x power. Okay, so we want to rewrite it as y equals 1 times 2 to the x power to make it mirror this. Okay, so that function is y equals ab to the x power. A is going to be our starting amount. B is our growth factor. X is the number of repetitions. Okay, so going by our format here, y equals a times b to the x power. Okay, a is our starting amount or our principal, b is our growth factor, x is our number of repetitions. The b is always going to be a positive number because we wouldn't be able to create a function with b being negative. It would look kind of all wacky and all over the place. So b is always going to be a positive number. Now, if b is greater than 1, then the function is going to be an exponential growth function. If b is less than 1 but greater than 0, it's going to be an exponential decay function. Okay, so an exponential growth function will look something like that. Okay, exponential decay function probably looks something like that. Now, in the exponential growth function, y equals ab to the x, a is the initial amount, and we could also represent a with p for principal. All right. B is a growth factor, x is the amount of time. Okay. What we can redo with the b, okay, b is a growth factor. Growth factor is how much it grows. Okay. So b is going to be equal to, and I'm going to put it out here, it's going to be equal to 1 plus our rate. It's going to be 1 plus our rate. Okay. Now that's going to be for growth. Okay, if it's for decay, which we'll talk about a little later, it'll be 1 minus our rate. Okay. And what we're going to do is we're going to change the x to t, which represents time. Again, not really changing the function. We're just changing some of the letters around to make it apply more to real life. Okay. So instead of y being a b to the x power, okay, it'll look like this. It'll be y equals principal times 1 plus our rate to the power of t, which is time. Okay. So y is going to be principal times 1 plus our rate to the t power, for t being our time. Okay. Same function, just change the variables around a little bit to make it a little bit more palatable to what we're going to be looking at here. Okay. So let's start with this example right here, the computer's one, and then you guys can do numbers 28 and 30 on your own. So Here in 1996, there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by about 92% each year. Okay, they increased by about 92% each year. Okay, so we know that 1996 is going to be year zero. Okay, now starting, let's talk about our A, right? Our A is our initial number of viruses. Okay, that's going to be 2573. Our B, remember, our B is going to be one plus our rate. 1 plus our rate. Well, what's our rate? The number of incidents increased by about 92% each year. So we're going to add 92% to that, or 0.92. Okay. So our B is 1 plus 0.92, which is equal to 1.92. All right. So if we want to find out the total number of viruses, okay, the total number of viruses, we're going to have Y equals 1.92, or check that. Y is equal to 2573 times 1.92 to the X power. So they were to ask us here, write a model given the number of N incidents T years after 1996, about how many incidents were there in 2003. Well, 2003, okay, how many years is that? Well, 1996 is year zero. So 2003 is going to be 7 years. Okay, so for the number of incidents in 2003, okay, we'll do 2573 times 1.92 to the 7th power. Okay. Next, we can graph the model. We can graph the model using Desmos if we want to. Okay. So we can go to our Desmos thing. Let me pull that up here. Computer going a little slow today. So here we can go Y equals 2, I think it was 2536. 2573. Whoops. 2573 times 1.92. Okay, so the X power. Now, if we're going to use a graph to estimate when there are about 125,000 computer security incidences here, all right, so we're going to look for, Y equals 125,000. It's going to be so far off the charts here. So Y equals 125,000. I'll have to estimate that here. And so that would be our point right there. If we wanted to plot that point, that point would be 5.953. So 5.953. So it's going to be about year 6. Okay, so year 6. So if 1996 was year 0, adding 6 to that would be about 2002. Okay. So that's how we would do an exponential function in real life here. We're going to do a lot more of these when we get to money and stuff, but this is a good application for doing it in a nice, simple way. So we can look at numbers 28 and 30 here on the backside of our 9B notes and try them out. And let me know if you have any questions. Thank you.